Okay, so this is going to be more a lecture around network discussion and security, but very important because I want you to really understand what goes on when a request comes from the client and goes all the way to your application. So sometimes we may want to block an IP address from a client because it's going to be a bad actor. Maybe it's trying to access our application. And so we want to know the line of defenses. So let's start from this very simple solution architecture in which we have an EC2 instance in a security group, in a VPC, and that instance has a public IP, so it's publicly accessible. And this is how our clients get into our EC2 instance. So say we wanted to block that client. The first line of defense would be the network ACL in our VPC, which is at the VPC level. And in this network ACL, we can create a deny rule for this client IP address. Very simple, very quick, very cheap, and the client will just be ejected. Then for the security group of the EC2 instance, we cannot have deny rules, we can only have allow rules. So if we know that only a subset of authorized client can access our EC2 instance, then it is good in our security group to just define a subset of IP to allow into our EC2 instance. But if our application is global, we obviously don't know all the IP addresses that will access our application. And so the security group here will not be very helpful. Finally, you could run an optional firewall software on your EC2 to block from within your software the request from the client. Now, obviously, if the instance has request already reached your EC2 instance, then it will have to be processed and there will be a CPU cost to processing that request. So it's a very simple use case, but we see already the difference between a NACO, a security group, and a host firewall. Now let's push this one step further. We introduce an application load balancer. So again, this ALB is defined within our VPC, and we still have our EC2 instance, but now we have two security groups. We have the ALB security group, and we have the EC2 security group. And so in this case, our load balancer in this architecture is going to be in between our client and our EC2, and it will do something called connection termination. So the client actually connects to the ALB, which will terminate the connection and initiate a new connection from the ALB into our EC2 instance. In this case, our EC2 security group must be configured to allow the security group of the ALB because the EC2 instance can be deployed in a private subnet with a private IP, and the source of the traffic it sees comes from the ALB, not the client. So from the security group perspective here, we only allow the ALB security group, and we're safe on this side. Now for the ALB of the security group of the ALB, we need to allow the clients. And again, if we have a range of IP we know, then we can configure the security group. If it's a global application, we have to allow everything. And then our line of defense is going to be at the network ACL level. Okay, this makes sense, and this should be something you already know. So with the network load balancer, it is quite similar now, where you attach a security group to your network load balancer and a security group to your EC2 instances. You make sure the rules allow traffic from the network balancer into the EC2 security group, and from the NLB security group from the client, and you have control of the traffic along the way. Now let's go back to our application balancer and see how we can filter traffic even more. Something we can do to deny an IP is to install WAF, or Web Application Firewall. Now this WAF is going to be a little bit more expensive because this is an additional service and a firewall service. But in here, we are able to do some complex filtering on IP addresses, and we can establish rules that will count for the request to prevent a lot of requests going at the same time from the client. And so we have more power over our security of our ALB. And so WAF is not a service in between your client and your ALB. It's a service we have installed on the ALB, and we can define a bunch of rules. So this is one more line of defense. Similarly, if we use CloudFront in front of the ALB, CloudFront sits outside our VPC, okay? So as such, our ALB needs to allow all the CloudFront public IPs coming from the edge locations, and there's a list of it online, but that's it. So coming from the ALB, it does not see the client IP. What it sees is the CloudFront public IP. And so as such, the network ACL here, which sits at the boundary of our VPC, is not helpful at all because it cannot help us block the client IP address. And so in this case, if we are trying to block a client from CloudFront, we have two possibilities. Say we're attacked by a country, then we can use the CloudFront geo-restriction feature to restrict all the country from a client to be denied on CloudFront. Or if there's one specific IP that annoys us, we can again use WAF, or Web Application Firewall, to do some IP address filtering, just like we did before. But so as we can see, based on the architecture we have different line of defenses to block an IP address. And they're normal. Once we put everything together, it all makes sense. But I think it's so good to show you exactly through a diagram what happens from a network perspective, how to properly configure your security group, and where to set up your IP address filtering. Okay, I hope you understand this lecture. I hope it makes sense, and I will see you in the next lecture.